Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to show you reactions of carboxylic acids. So, pre-laboratory questions, because you should know some questions before the lab. Draw the structural formula of the following compounds: acetic acid, monochloroacetic acid, trichloroacetic acid, benzoic acid, oxalic acid, succinic acid, lactic acid, propionic acid, citric acid, and propionic acid. So this is the structure of acetic acid. This is the structure of monochloroacetic acid. This is the structure of trichloroacetic acid. This is the structure of benzoic acid. This is the structure of oxalic acid. This is the structure of succinic acid. This is the structure of lactic acid. This is the structure of propionic acid. This is the structure of citric acid. This is the structure of propionic acid. Now write the equation that shows the ionization of valeric acid in water. So you can see the valeric acid in water, it gives the H3O plus and COO minus. So write equation showing the reactions of valeric acid with sodium hydroxide and sodium bicarbonate. You can see sodium hydroxide and with sodium bicarbonate. What is the difference? Only byproduct. In bicarbonate, carbon dioxide and water remove. Here you can see, so sodium is replaced by hydrogen, or hydrogen replaced by sodium. Now result and discussion. What you have to write? Acidity and structure. Acetic acid, monochloroacetic acid, and trichloroacetic acid. You can see the pH. Acetic acid 3.0, monochloroacetic acid 2.0, and trichloroacetic acid 1.0. So trichloroacetic acid is more acidic because of the presence of 3 chlorine atom, which tend to pull the electrons closer, leaving the hydrogens more prone to leave. Now solubility. You can see here acetic acid in water and with sodium bicarbonate 0.5 ml. You can see the benzoic acid did not dissolve, and oxalic acid 0.5 milliliter and lactic acid 0.5 milliliter. So effect of oxidizing agent: formic acid purple to green with the cheminophore, heating green to brown after heating. So silver mirror formed. Acetic acid no change in color in cheminophore, no silver mirror formed. Lactic acid purple to green without heating, green to brown after heating, no silver mirror formed. Propionic acid purple to bloody red without heating, bloody red to clear solution after heating, no silver mirror formed. Citric acid purple to clear solution, no silver mirror formed. Tollen reagent. Oxalic acid no change in color and no silver mirror. Benzoic acid no change in color, no silver mirror formed. Propionic acid purple to reddish brown after heating, and Tollen reagent no silver mirror formed. Propionic acid purple to reddish brown after heating, and water no change in color, no silver mirror formed. So this is the effect of oxidizing agent, 2 oxidizing cheminophore and Tollen reagent on formic acid, acetic acid, lactic acid, tartaric acid, citric acid, oxalic acid, benzoic acid, propionic acid, and water. Now you can see the formic acid, propionic acid, tartaric acid, citric acid, and acetic. So oxalic acid, lactic acid, or lactic, benzoic acid, or benzoic. So discussion for cheminophore. Carboxylic acid are relatively resistant to oxidation. However, some acid like alpha hydroxy acid may be oxidized. So you can see acetic acid and lactic acid. So, discussion for Tollen's reagent. Mild oxidizing agent like Tollen's reagent are easily reduced by aldehydes to silver mirror. This is the formic acid. So, esterification smells like guava, did not dissolve in water. Discussions. There are two evidence of esterification reaction. The change in solubility, the product ester is not water soluble. So, two layers were formed. A distinct change in odor, and they are usually sharp and extremely pleasant. Now, carboxylic acid in its salt. Cold water, salicylic acid did not dissolve. Hot water, salicylic acid dissolved. When cooled to room temperature, crystal were formed. Addition of 3m sodium hydroxide is element flask, crystal were dissolved. Addition of 3m hydrochloric acid in element flask, crystal were formed. So now questions. What is the effect of chlorine on the acidity of carboxylic acid? You know, chlorine is electronegative, which tends to pull electron closer to them, leaving the hydrogens more readily to leave, making it highly acidic. Explain the effect of a structure of samples used on solubility behavior. You can see the acetic acid, and you see the monochloroacetic acid. Now you can see the trichloroacetic acid. You can see the benzoic acid. You can see the oxalic acid. You can see the succinic acid. You can see the lactic acid. You can see the tartaric acid. You can see the citric acid. 3 COOH groups is present and 1 OH groups. So propionic acid. Now write the equation showing the ester formations. Then conclusions. In conclusion, the structure of the compounds plays an important role in its solubility. Electronegativity plays a big role on the carboxylic acid's acidity. Carboxylic acid are usually resistant to oxidation or oxidization, but there are some cases that they can be oxidized. So my friends, I hope this video will be beneficial for you. If you like this video, then subscribe my channel. Thanks for watching.